Hi, I'm Anderson Tsang. Welcome to my IDS presentation. This year for IDS, I built a neural network to catch griefers. If you've been living under a rock, a neural network is a type of algorithm that lets computers do extraordinary things. Deepfakes, AlphaZero, these chat boxes on government websites, the list goes on. Neural networks are becoming a part of our everyday lives. As for griefers, hopefully the skit made it clear, but griefers are people who try to ruin other people's fun on game servers. It's happened to me more than a few times, and it's really depressing to see your hard work, whether it's a fancy house, time spent, or rare loot, go up in a plume of smoke. When I wrote the project proposal, a system like what you just watched was what I envisioned. With the background now set out, let's move on to the code. To write my neural network, I used Python and TensorFlow. As we all know, Python is one of the world's most popular programming languages, while TensorFlow is a machine learning framework backed by Google. Combining these two, I was able to create a neural network that can detect malicious persons, wait for it, 94% of the time. Of course, there's a small few inconsequential caveats. The first is that neural networks require a lot of training data. This means they need to go through hundreds or even thousands of entries before they can perform reliably. I do not have thousands or even hundreds of players to collect data from. In fact, I have none because I do not own a game server and no one has made a dataset with these parameters in mind. So, I whipped up some code to create FOSS data, links in the description. This replit generates a CSV file with random player statistics. While this was kind of fun to do, it also meant I had to somewhat abandon my written IDS plans, as I was hoping training data wouldn't be so mandatory. Also, I find it likely that for some obscure mathematical reason my fake data generator isn't as random as I think it is, but that's neither here nor there. The second caveat is that neural networks involve a depressing amount of university-level mathematics. I do not have knowledge of university-level mathematics, nor did I have the time to learn about university-level mathematics. Therefore, it is entirely possible that the method I'm using is the completely wrong one. Finally, let's look over the final product. We're using a Google Colab notebook as it's not only free and fast, but it's also better than a traditional code editor in some aspects. There's a respectable amount of code, so in the interest of time I'll skim through to the most important parts. The notebook is in the description and it's free to use if you'd like to play around with it. The first half of the program is all set up to create a neural network. For several critical reasons, TensorFlow requires that you structure your data in a specific way before training your neural network. This is great for performance, but does require a lot of additional libraries to package the data. This here is the meat and potatoes. In the space of 7 lines, we initialize, then begin training the neural network. Because this is relatively speaking a pretty simple process, it takes only a few seconds. Once the neural network is trained, you can easily use it to predict the outcome on other pieces of data. Again, I'm glossing over a lot of the practical implementation as it will literally take 2 years to explain. Obviously, this isn't how I hoped the project would go. I didn't exactly have high hopes in the first place, but this isn't quite practical. For technical reasons, this program only runs on Python, unless you implement an API, but that's a lot of additional work. Even if I could make it magically work with any software and interface it into a game, I don't actually know if this neural network model will actually be useful. I also started on the majority of this project later than I hoped to. During this project, I do think I learned a lot about a completely new field, so next year I would like to... That's all. Thank you for your time.